All right, derivatives assignment, problems 1 through 3 have to do with this function, y of t equals 100t minus 16t squared. I've graphed our function y of t, drawn the graph. You may remember from previous classes that t squared, it's parabola, negative number in front of the t squared, it opens down. Yes, there's more to the parabola there and there. I didn't graph this part because let's assume that time is not negative for this class, it's fine. And then height, the height of an object above the ground doesn't really make sense to talk about the height of the object into the ground. So that's why I don't have that graph there. Okay, basically what we're doing in problems 1 through 3 on the derivatives assignment, which is now due tomorrow night and not last night. So if you didn't finish it last night, no problem. You can have till tomorrow, okay? All right, so basically what's going on is that, okay, we're trying to find the instantaneous rate of change at 1.7 at t equals at the point 1.7 y of 1.7. So at this point here, okay. So here I have the tangent line. You probably can't even see. Doesn't look like you can see that there. All right. Oh, you can see that there. Okay. Why didn't you tell me sooner? Okay, just kidding. All right, so here I've drawn the tangent line here. Let me try and make that as bright as possible. Okay, I've drawn a tangent line there. Tangent line, and we're gonna try and find the slope of that tangent line. Okay, the old skill, right? The old skill before was that we drew a bunch of secant lines, or we computed the slopes of a bunch of secant lines, like so. Secant lines. And notice that as we pull the point back towards this point, the secant lines become the tangent line. Okay, and so that's the idea, is that the old skill was you computed slopes of secant lines, and then you were to guess the slope of the tangent line. Okay, now we're going to be a little more systematic using derivatives. Okay, all right. Okay, so problem 1. So problem 1 first. So we're going to compute change in y over change in t over the interval 1.7 x. X is just some number. Let's see, I should have left this up, right? But anyway, let's see. Here's my 1.7. X is just some guy out there, so I'm computing the slope of the secant line, 1.7 to x. And then we're going to think about what happens when x gets pulled back and it becomes the tangent line, okay? All right, so change in y, change in t, over, let's see, remember the interval was 1.7x, 1.7x, okay? So it's y of x minus y of 1.7 over x minus 1.7. X minus 1.7 there. Okay, Now if I put an x in for t, okay, I get that. I put a 1.7 in for t. Like so. All right. Now, if you compute this with a calculator, 100 times 1.7 minus 16 times 1.7 squared, let's see, you get 123.76. All right, I think if you were to enter this into WebAssign, that would be your correct answer. Okay. Now we can simplify it, make it look a little nicer, but at this point, for problem 1, this is your answer. It's good. Now in problem 2, let's see, problem 2, you have to compute secant slopes. This is your secant slope from over the interval 1.7x. In problem 2, you have to compute the secant slope 1.68, 1.70. Now I know that this is switched around here. It really doesn't matter for a reason that I don't want to go into right now. All right, so now look, this is your formula, right? This is your formula that we have. It's this guy here. This is your formula from problem 1. All right, problem 2, to compute the secant slope over here, you can go ahead and plug in 1.68 in for x in both of these, find that number, and that's your answer, okay? The next one is 1.69, 1.7. You can put the 1.69 in there and in there, and that'll give you your answer, okay? That's what you're doing for problem 2. All right, continue, there's a few more to do there. All right, now you'll notice in problem 2 that when you have 1.7, 1.7, it's undefined, right? Now why is that, right? Now think about this, right? 1.7 in there would give you a 0 in the denominator, and putting 1.7 in for x and x squared here, you'll get a 0 on top. Okay, what this tells you is that this thing will factor. This thing has a factor of x minus 1.7 in it. All right, so now, so for problem 3, compute the velocity at the instant t equals 1.7. All right, so now what I'm going to do is I'm going to simplify this guy a little bit in a number of steps. So first, I'm going to factor out this negative, and I'm going to make the x squared term positive, okay? 16x squared minus 100x plus 123.76. Now, because when you plug in 1.7 in for x, you get 0 over 0, what that tells you is that there's a x minus 1.7 in the top. Need that negative there. Okay. Okay, so right, so now we just have to figure out how it factors, all right? So I know that it has a factor of x minus 1.7. There we are. Okay, now we just need to figure out what goes here, right? Something x plus something. Who knows what that is? Okay. All right, well, notice that whatever we have here is going to have to FOIL back to this right here. Okay, so think about, so what times x is going to give you 16x squared. So it's going to be a 16 there. Okay, and now let's think, okay, now, right, so that was the first, right? The firsts give you 16x squared, and the lasts, something times negative 1.7 is going to give you a 123.76. Well, first of all, right, if it's a negative here and that's positive, we got to have a negative there. Right, so negative times a negative is a positive. Okay, now what times 1.7 equals 123.76? All right, so 123.76 divided by 1.7. What does that equal? I already did the math. 72.8. So I know I need a 72.8 here. Okay, so here's what I got from problem 1. I did some factoring. Cancel those. You get negative 16x minus 72.8. Distribute the negative through. 72.8 minus 16x. Now you want to evaluate, okay, so dy dt at t equals 1.7. Okay, dy dt, really same thing, change in y, change in t. Okay, so the vertical line, think of it as saying evaluated at 1.7. So, really kind of overdoing the notation here. It's really fine just to think of it like this. So we're evaluating this formula, evaluated at t equals 1.7. Plug that in there. And that should give you your answer. I'll let you take care of the units. Right, good luck. You can get this done. This is due tomorrow night now, okay?